even, right? The index is even. So going back to this pointer right here, if the index is even, but the value on the other side is negative, there's no solution. But what's the index over here in this example? It's odd. So we don't have a problem. We can keep going. No problem there. Alright. Now what do I do? It's already being cube rooted. Cube. So we're going to cube both sides. So it means you're going to take everything to the power of 3 on this side and everything to the power of 3 on this side. That just means that the root goes away and you're left with the radicand. Everything in the radicand stays. And then I'm going to cube negative 3. Now notice how I put it in parentheses. You're going to do negative 3 times negative 3 times negative 3. It's going to stay negative. Because a negative number cubed is going to stay negative. Alright, now what? Now you subtract 2. So I get x equals negative 29. Now that's the solving process. So we got to our solution, x equals negative 29. But again, every single time you guys are doing these problems, you want to make sure that you're double checking that it's correct. So I'm going to take the negative 29 and I'm going to plug it in to the original question. You can type that into your calculator. The cube root, which I think is like math 3, I think, is how you get a cube root. The cube root of negative 29 minus 2, close the cube root, and then add 5 to that. You get 2.
Wait, I thought it would be plus 2. Yeah.
No, you're plugging it into the top equation, the one that's printed.
Yeah.
You get 2? Okay, so then
I got
they
it.
are equal, then you're good. You do the cube root of negative 29 plus 2, close.
Then you have to put an arrow to get rid of the square.
Or you can just push enter, find that number, just push enter, find that number, and then to that number add 5. And then you should get 2. Okay, there you go. So that's how you check. That's how you check to see if the answer was correct. So your final answer is negative 29 and you're good. Alright, what about for example number 2? Subtract the 8. Alright, so leave everything else, but just subtract the 8. So that's going to make this negative 13. Then what?
Square root.
Nope. 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 You have to get rid of this first. I know, Nick, you were thinking, oh, it's negative over here and that's a square root, and I'm glad that you're remembering that little bullet point I brought up, but you have to make sure you take care of all the operations first before you make any decisions about that. So I'm going to divide by negative 1 to take care of that negative. That gives me the square root of x is positive 13, takes care of that negative issue that we potentially could have run into. Now that I'm here, what do I do? Now I can square. Now that this is finally by itself, it's isolated, I can square both sides. That gives me 169. Okay? And then just really, really quickly, you're going to check to make sure that's correct. You're going to do the negative square root of 169 plus 8. Make sure that's equal to negative 5. Should check out. That would be your final answer. Right? Pretty simple stuff so far, right? Alright, what would I do in here? Subtract 4. So I get the square root of x plus 2 is equal to negative 4.
This one.
Do I square?
Yeah.
No.
Wait.
No, it's a negative.
This time, the radical is isolated, but the number over here is negative. Is it ever possible to have the square root of something be just negative 4? No. So this one would be no solution. You would never be able to plug in a value of x into this radical, take the square root of that, and just get negative 4 as a solution. Okay? So again, keep your eyes peeled. Anytime you have a fully isolated radical that's a square root for an even index equal to a negative number, no solution. Alright, now here, number 4 is our first example of a rational exponent. Sorry. So this one is not a square root or a cube root or anything. It has that fraction exponent. So there's just one extra step that you guys do here. You just need to turn it into a radical first, and then go along with everything you've been doing so far. So I'm just going to look at this really quick. I'm going to take whatever has a fraction exponent. I'm going to turn it into a radical. So the fraction is 1 over 3. So what's the index? 3. So this is a cube root. I'm going to leave this in parentheses for now. 2x plus 8, and then what's the power? 1, so I'm not going to write it. It's fine. and then I have a plus 4 on the outside, and then equals 12. So whenever you guys have that fraction exponent, just do the conversion first, and then you guys can proceed with the normal solving, like we were doing in the upper ones. Alright, so what do I do first over here? Subtract the 4. I'm going to drop the parentheses. It's just addition, there's nothing being distributed, so I'm going to drop that. So it becomes 8.
Cube.
Then you cube. In order to cancel out a cube root, you're going to cube both sides, so that drops the radical symbol. 8 times 8, 64 times 8. 512. Now what? Very basic algebra from here, right? Subtract the 8, divide by 2. So 504, 252. And then again, really quickly, you want to make sure you check your answer. So here you guys can either plug it into the original one that's printed, or you can type it into the one after you converted. Either one is fine. So I'm going to go ahead and use the radical one. So you can do the cube root of 2 times 252, or I'm just going to write 504. Or 512. And then plus 4, and I want to make sure that equals. So check out. Alright, what about this one? I want to convert first, right? Convert it to a radical before we get started. Now, here's where you guys have to be careful again about the whole conversion thing. See how there's a 2 in the front and then x to the 3 halves? Is the 2 going to be inside of the radical? It's going to be outside because the 2 doesn't have a fraction exponent, okay? So the 2 is on the outside, and then for the x, which is the only component of the radicand, what's the index for a radical? 2, so it's a square root, x to the 3rd, right? Alright, so we have the plus 1, and I'm just going to... Okay, now that we've done the conversion... Nope, we don't have to simplify. That would be if you were trying to simplify the expression. We're trying to solve for x now. So if you were to undo, it would be way more complicated if you tried to simplify that. Alright, now what? Subtract 1. Then what? Okay. What was it? 120. 120. Making sure. And then what? And you square both sides because it's square rooted. So to get rid of the square root, you're going to square both sides. I have no. That's a big number.
It's
15. What?
16.
And I'm sorry, my handwriting is very weird.
Square root.
No, it's square. Why would you square root it?
Square root. Wait.
Why would you square root it?
Oh.
You're squaring. Do the inverse of what's already there. And now I'm going to have to cube. So with the square root, to undo a square root, you square, but now this time it's a power, so then you would use the root to get rid of the power. So this time we're going to take the cube root of that number. I hope that's a whole number. It's 25. That's cool. That worked out. So the cube root of 15,625. Works out nicely from 25. Alright, and then again, really quickly, you guys can just make sure that this is correct by plugging it in. So you guys would do, over here, you do 2 times the square root of 25 cubed. Add 1 to that, and make sure that it's equal to 251. Just use your calculator, type in some numbers. Check out for us. Now these bottom 2 are going to be different. Bottom 2 are going to be a little bit different how we work with these. Okay, so just bear with me as we're going through. Alright, what do I do first with this kind of scenario? Convert to a radical, so that we're on a kind of more common ground with the solving process. So if I have this one in parentheses, this is the only one that's going to go in a radical. The exponent right now is 2 over 3, so which one would be the index? 3, so I have the cube root of to the 2nd power, right? And then we have the random minus 4 on the outside equals 0. Oops. Alright, now what? Add 4.
Cube.
Cube, so it's currently a root, so you want to undo the root by using the power that matches the index. I'm going to cube, it's wiggly writing, 64, right?
Yeah.
Sorry, that's a 64, that looks kind of strange. Oh, sorry, I accidentally dropped this away. That's squared. It's only the root that's going to peel off, that power is still there on the inside. So I took care of the root part, now I need to take care of the square here. So I'm going to square root. So that means I'm going to have x minus 1 equals plus or minus 8. Plus or minus 8. Okay? And then there's one extra step that I'm going to have to do here. You have to add a 1, right? Now, do you guys remember how you do this kind of scenario? It is technically 1 plus or minus 8, but aren't these like terms? So you wouldn't leave it looking like this. Because they're like terms, you can actually do the operation. You can do 1 plus 8 and 1 minus 8. No. What's 1 plus 8? 9 and 1 minus 8. Negative 7. So you have two answers, 9 and negative 7. I should not have circled it like that yet. Hold on. 9 and negative 7. When they're like terms, when you guys have this scenario with the plus or minus, and you have two things on either side of the plus or minus, if they're like terms, you have to actually do the two different scenarios to find two separate numbers. Because you can't type in 1 plus or minus 8 to check your answer. You can't do that. So,
When do we do the plus or minus numbers?
whenever you're taking a square root. Okay? So now you guys have two possible answers, you have to check both of them. Usually when you guys have more than one answer, that's when extraneous solutions pop up, is when you have more than one answer. So now we're going to have to check both the 9 and the negative 7 to make sure that they both work. So I'll give you guys a second to do that. So you guys would do if you're checking, if you plug in the 9, that would be 8 squared. You plug in 9 here, that would become 8 squared minus 4, and then if you plug in the negative 7 there, it would become negative 8 in parentheses squared minus 4. You want both of those to equal 0 for them to be solutions. So they both work, therefore you have two answers, which will happen sometimes. You have two answers. Alright, let's try this one. Then we'll go on to some slightly more difficult ones on the other side of the page. Yes, that would be where one of them would be extremes. We'll see an example or two. Alright, so for this one, what would I want to do first? I mean, you could do that first if you wanted to, but essentially, I need to fundamentally change how this is written. What? Change this to a radical first. That's what I personally like to do, is do the conversion first before I try to do any algebra, because then things might get lost. So I like to do the conversion. So the denominator is at 5. Okay, so the denominator is a 5, so the index is 5. Then I have x plus 2 squared. Okay, so there we go. Equals 2. I just like to do that first. Alright, now what do I do to try to get the radical isolated? Divide by 1/2 is the same thing as multiply times 2. So you can get rid of the 1/2 by multiplying by 2 on both sides. I can get 4 over here. That right? You need to get rid of this root, right?
Yeah, put the 5, I don't know what it's called, but
It's just fifth
4
power.
fifths.
Fifth power. So because this is a index of 5, to cancel out the root, you're going to use a power of 5. So you're going to take the fifth power of both sides. That cancels out the root. That's the point of doing that. Sorry, it's wiggly writing. X plus 2 squared stays. Whatever is in the radicand is totally preserved. Nothing changes. 4 times 4 times 4 times 4 times 4. Okay. Cool. Now what? Now you can square root. Is that a whole number? Oh, that's cool. So what do you write here? Plus or minus 32. Remember when you take a square root, make sure you include the plus minus. And then again, just like over here, when you have a number by the x, you have to move it over. So that'd be negative 2 plus or minus 32. But are these like terms? They're both constants, right? So then you would go ahead and write them as their two separate values. Negative 2 plus 32 is 30. And negative 2 minus 32 is negative 34. Right? Again, you'll be able to tell that you have to go further because you can't physically type negative 2 plus or minus 32 into the equation to check it. So that should be a reminder, the check process should be a reminder, oh, I need to actually get numbers from this. So you're going to plug in 30 and negative 34. I'll let you guys take a second to do that. See if we get any extraneous solutions in this one. Huh? 30 works? Okay. Awesome. So then you have two solutions. Both of these are going to work out. I promise we will see one that has an extraneous solution. They're rare, but I still want to make sure you guys see the example. So go ahead and turn the page. So the ones we're going to see over here on this side are a little bit more complicated. The really only difference that you guys will see is that you're going to have either two radical expressions, you're going to have two square roots, or you're going to have two different appearances of an x for the variable. The variable could be inside of a radical and then also outside. So the way you work with them is a little bit different. Usually the extra step is factoring. You have to solve this by factoring, which again we've been practicing for a really long time. So again, the process of the solving solution is stuff that you guys already know right now. It's just going to take a little bit longer. Is what makes it a little bit more complicated. So for example, we have this one right here. We have a radical expression, then we also have an x on the other side of the equal sign. Again, your process is still the same. Whenever you have a radical expression, you need to make sure this is completely isolated by itself. So once you get the radical by itself, which, yeah, so we started over here. So the first thing I did was add the 3 to get the radical by itself. Then to cancel out the radical, I have to square both sides. So actually it works out really nicely. I got the radical to cancel over here. But because I'm squaring, remember how much I emphasized about the difference between when you can distribute a power and when you can't. Last lesson, we were distributing our powers really happily. It was working out really nice for us because it was all multiplication and division stuff, right? But I can't distribute here because the operation is addition. So, whenever you have a power outside of parentheses and the expression inside has addition or subtraction, you guys have to FOIL. Remember, squaring is multiplying something times itself. So you're going to FOIL this expression, you're going to get everything over to one side, and then factor it. Okay? Now what happens over here, this is actually an example of an extraneous solution. If I take 1 and I plug it in, right there, into the original equation here, or sorry, this one. If I plug in 1, if I plug in 1 there, it actually works out that I get 1 equals 1. Works out nicely. But if I take the negative 8 and plug it in, I would get the square root of 25 minus 3, which would be 5 minus 3, which is 2, does not equal negative 8 when you plug it in over here. So this is an example of an extraneous solution. I did everything perfectly fine. I factored. Everything was good. Awesome. But when you get to the end, one of those numbers actually doesn't work. Okay? So your final answer would only be, like if you were writing this, you would then draw an extra line and just say it was 1 without the negative 8. Okay? So, a little bit longer, but stuff you guys should still know how to do. So, let's look at this one right here. So I'm going to solve this. So I have two different radical expressions. What would I want to do before I can jump in?
Get 1 times.
Yeah, you want to make sure that there's 1 on each side of the equal sign. So I'm going to take this one and I'm going to add it over. So it becomes x plus 4 equals
2x minus
the square root of 2x minus 8. So you have 1 on each side. Now, I still need to get rid of the radical, but it's actually nice. I'm going to kill two birds with one stone. If I take the square root of one side, what do I have to do? Sorry, when I take the square of one side, what do I do with the other? Square it as well. So I can actually get rid of both of the square roots at the same time. If you square both sides, everything kind of cancels out and it becomes really nice and easy. So it looks scary at the beginning, but it actually works out to be really easy. And then from here, it's just basic algebra, so I'm going to subtract the x, add the 8, and I get 12. Then really quickly, I'm going to either do mentally or my calculator, I'm going to go ahead and plug the 12 in. So when I plug in 12, 12 plus 4 is 16, so that would be 4 here. And then 2 times 12 is 24 minus 8, is that 16 again? So then the square root of 16 minus the square root of 16 equals 0, checks out, so 12 marks. Okay, so it looks scary, but it's actually kind of easy. Alright, what about this next one? Is the radical by itself already?
Yeah.
Okay, so then we can just go ahead and start working. So what do I do to get rid of the radical? I square, because this is a square root, I'm going to square both sides. So then the radical drops, but this is x squared now. Well, I mean, yeah, but you're going to do it one at a time? What would I have to do in this scenario? How would I solve something like this? With an x squared, an x, and a number.
You gotta bring it to the other side equals 0.
Okay, so we need it to be equal to 0.
So add, or minus, so negative x squared plus 4.
I personally would like to keep the x squared positive.
So minus 4x.
So pull this over here. Yes, you have to be factoring. I prefaced this entire thing by saying that. Alright, whenever you guys have x squared, x without a square, and then a constant, you factor. Okay, it won't always be set up nice and orderly for you on one side of the equal sign to begin, so you're just going to have to remember to pull everything over. So once it's on one side of the equal sign set equal to 0, use factor. So that means I'm going to use the trinomial x trick, because it's a trinomial. So first times last is 3, middle term is negative 4. What multiplies to get 3 adds to negative 4. Okay? So then I have x squared minus 3x minus x plus 3, split down the middle. What's the GCF on the first side? GCF on the second side, be careful. Negative 1. And it depends on which one you go first. You should get the same factorization regardless of which one you go first though. Okay, so this is the factoring, but then what are the actual solutions? 1 and 3, potentially. Remember, one of these could be the sneaky false solutions. Never assume that you're done right here. So now we're going to check really quick. I'm going to take the 1 and plug it in. 4 times 1 is 4, minus 3 is 1. What's the square root of 1? And then if I take 1 and plug it in here, it's 1 equal to 1. Awesome, so 1 works as a solution. Then I'm going to take 3. 4 times 3 is 12. 12 minus 3 is 9. Square root of 9 is 3. And when I take 3 and plug it in here for x, 3. So 3 equals 3, both of them. Okay. Alright, moving right along. What would I do for this one? This is always the first thing you want to ask yourself when you're doing these problems. Is the radical expression by itself? Because that's your first goal. Because really you just want to make sure the radical expression is by itself and then you can jump into the solving process. So it is, right? So then once the radical is isolated, your next task is to cancel out the radical symbol. So what would I do? You would square both sides. So that's going to give me x minus 3 squared over here, and then just 4x because the radical drops away. And then FOIL, remember you cannot distribute that square if there is addition or subtraction inside. So I'm going to FOIL, and you guys can physically, if you want to, underneath or off to the side or something, you guys can physically write what it means to square something is multiplied times itself. I can FOIL in my head pretty quickly. The more you practice FOIL, you can see that there are patterns that you can use to do it quickly. You'll get x squared and then negative 3x, another negative 3x, which combines to become negative 6x, and then negative 3 times negative 3 is positive 3. Right, so once you do all the FOIL, you'll get here.
Now you forward.
No,
Or, I mean, now you factor.
no, you do not factor at this point, no.
Can you
Adds.
You have to subtract the 4x over. Everything has to be on one side set equal to 0 before you can factor. So I'm
So
going to
negative
subtract, so negative 10x. You cannot factor to solve unless it's equal to 0. So make sure you're pulling everything over to one side. Now I can use trinomial. Negative 1, negative 9. It's negative 9. Split down the middle. Right? I'm sure you guys know how to do this by now. Hopefully you do. Factoring process gets you down to x minus 9 and x minus 1. What solutions do I get? You get 1 and 9. Again, we don't quite know if there's a final answer yet, so let's go ahead and check. So when I plug in 1 up here to the original question, I plug in 1. 1 minus 3 is negative 2. When I plug in 1 here, 4 times 1 is 4. Square root of 4 is
2. So 1 doesn't work.
So 1 actually doesn't work. Because on one side it said negative 2, the other side it said positive 2, or really plus or minus 2, but regardless, they weren't the same. So 1 didn't work. So now let's try 9. 9 minus 3 is 6. 4 times 9 is 36. Square root of 36 is 6. 6 equals 6. Okay. So this is an example where an extraneous solution pops up. You cross out the one that doesn't work, circle the one that did work, and then move on.
You have to extraneous solution and then a solution.
If it was going to be no solution, you would see it at the beginning, like we saw on the previous page with the negative number. All right, what about example 4? You have to add the x over. Your first order of business is to make sure that the radical expression is by itself. It's the very first thing you always do no matter what. So I have to add the x over. I'm going to write it as x plus 1 so it's in standard form as opposed to 1 plus x, just to make it easier to work with. Alright, now the radical expression is by itself. So now you want to get rid of the radical symbol by squaring. So it's going to give me 2x plus 1, but over here I'm going to be squaring this expression, which is a binomial. FOIL. Yeah, you can do that off to the side or you can do it in your head. Depends on how used to foiling you are. Now what?
It's already.
What does that leave me with? X squared equals 0. So what's the value of x? 0. So you get x equals 0, right? So I want to plug it in to make sure it makes sense. So when I plug in 0, 2 times 0 is 0, but 0 plus 1 is 1. 1 squared is 1. And then if I plug in 0 here as well, if there's multiple x's, make sure you're plugging it into all the x's. So it would be 1 minus 0, which is 1. So, we're good. Alright, I'm going to have you guys do the last two by yourself. I've done plenty with you. So now you guys are going to try this independently. Do the last two by yourself, and in a few minutes I'll put the answers up so you can check. Alright, so you guys should get 6 and 4. First one should have been pretty simple. You just take the cube, or you cube both sides to get rid of the radicals, and then it's just really basic linear algebra from there. This one, again, what's the first thing you want to make sure is happening? What's your first goal when you guys are solving? The radical is by itself, which is not the case here, so the first thing you do is divide by 4. Then once you get the radical by itself, your mission is to get rid of the radical, whether that's squaring, cubing, whatever. You want to take care of that. So when you do that, when you square, you're going to have to FOIL what's over here, and then you're going to have to factor. When you guys factor, you will get 2 solutions for and positive 1, but when you plug in positive 1, it doesn't work out. Okay? So then 4 is your only solution.
I got x minus 2 squared.
What?
Because when you FOIL, don't you get x minus 2?
Parentheses squared. So you FOIL that.
Yeah.
And then you pull the x over to factor. So you factor it, and then you would get 2 solutions, 4 and 1, but 1 doesn't work. Okay? So again, make sure your first goal is to make sure the radical is by itself, then you get rid of the radical using the inverse operation, and then you just use your algebra, working through it, remembering that if you guys see an x squared, an x, and a constant, no matter what order they're in, if you see an x squared, an x, and a constant, you will have to factor. So just make sure you get everything to one side, set equal to 0, factor, and then extraneous solutions pop up most often when you guys have 2 solutions. So be extra wary when you have 2 solutions, make sure you check them both to see if they both work. Okay? Any questions?